All right, so the first thing we're going to do for part A is prove that the derivative is equal to that. So in order to do that, we have to use implicit. So derivative of 2x squared is 4x. Derivative of 3y squared is 6y. Now here with the negative 4xy, we need a product rule, and you have to watch your negative. So it's negative 4x, derivative of y is dy dx. And then that negative is going to stay with that next part. So it'll be the derivative of negative 4x, which would be negative 4 times y. And then the derivative of 36, which is 0. Grouping together the dy dx's and dx dx's, we have 6y minus 4x dy dx. And then we're going to move over the 4y minus 4x. And then we can divide by the 6y minus 4x. So you get dy dx equals 4y minus 4x over 6y minus 4x. And then you can factor out a 2. And you get 2y minus 2x over 3y minus 2x, which is exactly what they told you to verify. All right, so the first thing we have to do in part B is find the y values when x is equal to 6. So what we're going to do is take the original and plug in 6. So that would be 2 times 6 squared plus 3y squared minus 4 times 6y equals 36. We're going to work backwards, turn this into a quadratic. So you have 3y squared minus 24y, and then subtract your 36, and then 6 squared is 36, but 36 times 2. So eventually it's just going to kind of even out, and you're going to end up with 36. We're going to factor out a 3. So you get y squared minus 8y plus 12 equals 0. So then we get that y is equal to 2 or 6, because we can factor that and solve down. So now what we need to do is find dy dx when x is 6 and y is 2. And then we also need to find dy dx when x is 6 and y is 6. So we're going to plug into the dy dx they gave me and had me verify. So you get 2 times 2 minus 2 times 6 over 3 times 2 minus 2 times 6. So you get 4 minus 12 over 6 minus 12. So then you get negative 8 over negative 6, which is a positive 4/3. Down here, you get 2 times 6 minus 2 times 6 over 3 times 6 minus 2 times 6. So you get 12 minus 12, and then you get 18 minus 12. Well, 12 minus 12 is 0, so it doesn't really matter what the bottom is. We get 0. So the slopes at the points when x equals 6 are 4/3 and 0. All right, so part C says find the positive value of x at which the curve has a vertical tangent line. Show your work that leads to your answer. So we're going to go right back to that original curve, and we are going to look at just the denominator of that curve. So when the denominator of the curve is equal to 0, we would have a vertical tangent. So we're going to say that 3y minus 2x is equal to 0. So in doing so, we get that 3y minus 2x would be equal to the equation y equals 2x over 3. So that's just simply a linear function. So we know that the line y equals 2/3 x would be able to be substituted back into the original. So we're going to take that 2x squared plus 3 times 2/3 x squared minus 4x times 2/3 x equals 36. And again, anytime that y is equal to 2/3 x would have a vertical tangent. So if I plug it back into the original and solve for x, I get the x values at which we have a vertical tangent. So you have 2x squared plus 3 times 4/9 x squared minus 8x squared over 3 equals 36. Simplify here, you get a 3. So now we can say 2x squared minus 8/3 x squared. Well, we know that this over 3 would be the same as 6. So 6 minus 8 would give me a negative 2/3 x squared. Here we have 1/3 x squared. So if I add 1/3 and negative 2/3, I get negative 1/3 x squared equals 36. And then I can multiply and simplify and end up getting a positive 2/3 when I simplify all of that. And flip it and get x squared equals 36 times 3 over 2. So 36 over 2 is 18. 18 times 3 is 54. So x squared equals 54. But the key part is that x is positive. So x would equal the positive square root of 54. Do not put the plus or minus because it only wants the positive. All right, so part D is kind of like a hidden related rate. We're going to find the derivative with respect to t. So that means that the derivative of 2x squared with respect to t would be 4x dx dt. The derivative of 3y squared would become 6y dy dt. The derivative of the 4xy, you could treat the negative 4 on the outside, take the derivative of the inside, so it would be first times derivative of the second plus second times derivative of the first. And then the derivative of 36 would stay 0 regardless of the dt. Clearing through all that, you get 4x dx dt plus 6y dy dt minus 4x dy dt minus 4y dx dt equals 0. And then I like to have dx dx and dy dy, so I would regroup them, but you don't even really have to do that because now what you can do is go back to what they gave you, which is that x is equal to 2, y is equal to negative 2, and at time t equals 1, the value of dy dt is 4. So again, this is just a related rate without being a shape. So we know that x is 2. We're looking for dx dt, so we're going to leave that. We know that y is negative 2. And dy dt is 4. X is 2. Dy dt is 4. Y is negative 2. And we're looking for dx dt equal to 0. So we get 8 dx dt. 6 times 4 is 24, times negative 2 is negative 48. 4 and 4 is 16, times 2 is negative 32. 4 and 2 is positive 8 dx dt. Get the 48 and 32 on the other side. 8 and 8 is 16 dx dt is equal to, and then when you add that over, it will become positive 80. And then you're just going to divide both sides by 16. And we get dx dt is equal to 5.